All right, so this is our last part in terms of data that you have to watch for our drug and poison analysis lab. So this is for the forensic science students in Hartford, New York. So we are going to do basically urinalysis tests to identify what is in someone's urine. So we are at this chromatography chamber, right? It's a glass jar with a cap. I've put into it what is called chromatography solvent. So this acts by a wicking action in an interaction of the solvent with your chromatography paper, and also with the material you put on the chromatography paper. So I am just going to do a quick measurement for myself here to see where the height is. If I stand my chromatography paper up there, I will know I want to put my start line above that. So when I put the chromatography paper into the liquid, this line is not below the top of the liquid. If you do that and it's below the top of the liquid, then what happens is your material just goes into the solvent and never goes up the paper. So I have to make a little adjustment here so I can see the edge of my paper. So I'll go up a little bit. Try to make this line go as straight across as possible. I'm using pencil because pencil will not go up the paper with the solvent. So you have to be careful that you can't use pen. Pen will be drawn up and it'll ruin your chromatography. I'm going to put a little dot. I have 3 pieces of things that I have to have analyzed. So these are my starting dots. I have alanine. It's an amino acid. So I'm going to put an A so I know I put alanine there. I put glycine here and the urine here. Right, so I'm going to do transfer now this material using what's called a capillary. I'm going to have to probably take my hand out of the glove. I use the glove so I don't get any oils of my hand onto the paper. So I don't, because the oils contain some of these amino acids, so you don't want to contaminate it. To use the capillary tube, you put your finger over the bottom. So you put the tube into the liquid. So I'm using my glycine control. I put my finger on the top. So I have all this liquid that's there, and I'm going to start dabbing it and letting it dry. Okay. Dab and let it dry. Dab. I don't like it. This spot's kind of big. I like them to be nice and tight so that when they travel up the chromatography paper, you don't have a really wide streak, you have a narrow streak, but the room isn't as dry as normal. Oops. I let go of that, so I've got a big blob. That's probably not going to work that well today, but we'll see how it goes. That's the glycine. I'm sorry, that was the alanine. It was not the glycine. See, I took the alanine control so that you know I didn't make a big boo-boo there. I said it was glycine, but it was alanine. So here's my glycine control. Control meaning it will behave a certain way, it'll run a certain way, and then we compare it to the urine. And see if I can make smaller little dabs here. I don't know if that alanine is going to mess it up because the dabs are awfully big, and that's an awfully big circle there. Okay. I'm going to pause the video for a second because I have to get these dabbed on here. When I'm all set up, I will bring it back. Okay, so I dabbed all 3 on there. The urine, here is the sample urine. It is dabbed on there. You might be able to faintly see it. Now, this is going, and I just touched that with my finger, so I hope that doesn't mess it up. This is going to go into the chamber. The chamber is going to act in a way where the liquid's going to start here, and it's going to travel up the piece of chromatography paper. Okay, I'm not going to have you watch it all the way because it takes a while. So I will pause the video and restart it once it's done. After it's done, we're going to take it out and I'm going to spray it with what's called ninhydrin. And when we take it out, though, we mark the top of it because we're going to measure distances and come up with this thing called the RF factor. The RF factor tells a person whether the material is the same material because it'll have the same value if it's the same material. And it's a distance traveled over the distance the solvent traveled. The liquid in here is called the solvent. I have a cap on that, so I put this in here. I'm going to cap it. Try not to disturb it, so it is in my little vessel. I'm going to switch cameras and see if this will work, guys. I haven't done this in a long time, so I'm going to see if I can get this to work. No, I don't want that. No. Close. Oh, I hate my mouse right now. Close that. I actually want to go full size on this, and I'm going to bring my camera over so you can see that the material. This is why I hate the camera the school's given us, because I do want to zoom in and I can't zoom in. It's all blurry and it will not autofocus. So over time, the solvent travels up that piece of paper. The liquid travels up, and you can almost see the shading differential. It's much darker up here. It's lighter down there. That's because the solvent's traveling up. So like I said, I'm going to pause it once the solvent gets all the way up to the top. And this may not travel too well, guys. I can already see it's really not traveling in a nice straight line across the piece of paper. So the things that I dabbed are going to go off at a slant. Ideally, you want the solvent to travel up in a nice straight line. For those of you in living environment who have not gotten to this point, and I don't know what they're doing for labs for the chromatography part of it, you would have learned how to do this in a living environment or life science. Okay? All right, so let me pause this. Sorry, it's really hard, guys, when I'm using my left hand that's got a glove on it. Hold on. And it's not registering on my mouse pad. So silly, isn't it? And all I want to do now is get out of this and pause. It's not letting me pause. It's not letting me change it. Want to close out? There. Okay, guys, so the solvent's run. It's hard to see it with the lighting, but the solvent top is right here, so I'm going to make a mark with a pencil. That tells me how far the distance the solvent traveled. And then I'm going to measure that because that goes into this part where it says how far did it travel. So I measure from, and I'm going to do it in millimeters because they ask for millimeters. Okay, so I start with the 0, and it's gone up to 64.5 milliliters because this is 65. You might say, well, that's a 6 there. That's centimeters. I have to multiply by 10. So that's 64.5 millimeters for all of these. Now I have to let it dry, so I'm going to pause it again. It's got to dry, and then I got to spray it with this material called ninhydrin. Where did I put it? It's a little squirt bottle, and then that has to dry, and then I can show you the chromatograph. So I'll let this dry. I'll be back in a sec. You won't know a difference because I'm going to stop the video, and then when we're done and I have the results, I'll bring it back. Alrighty, guys. So I pulled it out, let it dry, and then you can see the purple haze. So I think for measuring, take from there. This one's a little lower. The alanine's up here. So even just visual inspection, you can kind of see that the urine out of these two has something that runs more like the glycine. But this RF value, I now will measure from the start to sort of the middle of there. Using the inside of my protractor, I gotta do it to millimeters. So I'm at 25, 26, 27. If I look at my glycine, I'm about here's 10, 15, 16, 17. And this is less, so this is weird, but it's the closest. This is at 15. Now, this RF value is the distance traveled over the total distance, and you will get your value. So we're going to do that calculation. .49. Oh, no, sorry, 0.419. I'm like, no, it's not 41.9. This is 0.26. This is going to be really close to that, a little bit less. 0.23. These are close, so you can make your decision as to what amino acid is there.